All right, so the next presentation, keynote lecture from Petr Knoth. This one is a bit special because unfortunately there was a bit of a scheduling problem, so our guest speaker is online. So we will just broadcast his talk on Zoom. And just to tell you a little bit about him, he's a Czech native, but he's based in UK for many years now, and he wanted to participate remotely, like I said, because unfortunately he couldn't be here physically. Peter is a professor of data science at the Open University and founder of Core, a leading open access infrastructure serving millions of users worldwide. He will present connecting repositories, so Co and Re as Core, and an open scholarly infrastructure by researchers for researchers.
Thank you very much for the invitation. It's an absolute pleasure to be here, and I do apologize I can't be there today with you in person. I really appreciate the invitation though, because it's always nice to connect with the community in my home country. So I really do appreciate it. I studied originally at the Brno University of Technology, and in 2008 I moved to the UK, where I did my PhD and then have become a professor of data science. Today I will be talking to you about one of the key projects that I lead. It's called Core, Connecting Repositories, and I was kind of thinking about what I should tell you today, because Core is a relatively big beast, and I've been working on this for the last 15 years. And I realized that I will give like a short overview of what Core is, who it supports at the beginning, and then later I will tell you, because I lead a research team in natural language processing of scientific data, I will tell you how we use the data in Core to sort of support researchers, what research we do, and how we enable the research of others. So let me start with the first point. So what is Core? So the key mission of Core is to index all open access research worldwide and deliver unrestricted access to all of us. When I started working on Core, I was particularly motivated by the point that I realized that at the time, there were lots of research papers around the world which were stored in institutional, preprint, and other open access repositories. But actually, to be able to text and data mine those repositories, it was actually very difficult to put that content together and gain access and build things that today we find quite natural, and we all of us these days probably understand the value of having a large corpora of scientific data, because we are now familiar with things like ChatGPT, but in the past we were not familiar. Now we understand the potential a lot better than we did 15 years ago. So Core is a comprehensive bibliographic database of the world's scholarly literature. We originally focused on indexing open access documents, but we actually now focus on indexing all sorts of documents. It's just that those open access documents that we have, we can also text and data mine them, and we can host them directly within Core. We provide solutions for sort of content management, discovery, and scalable machine access to research. We are a not-for-profit organization. We are community governed, and we subscribe to the principles of open scholarly infrastructure. We also see the repositories community, the institutional repositories community, as an absolutely key to as a key community that we want to serve. What is in Core? So Core is really cares about comprehensiveness of the content. We've got about 400 million metadata records indexed by Core. And when I say metadata records, these metadata records can correspond to research papers, but they can potentially also correspond to things like research data. Research data we index at the level of the metadata. When we have papers, we index them both at the level of the full text and the metadata where this is allowed for us to do so. Indeed, we are a metadata and full text access provider, basically, in this respect. And we really care about giving back to the community. And so how do we do it? We do it by really working very closely with the community of repository managers to increase and tell them about how we can increase interoperability of these repositories, basically, because this is both in the interest of those data providers who want to expose the content basically to the outside world, make the content more discoverable, as well as us who want to provide the best possible service to anybody who wants to access those documents, whether these are humans or whether these are in fact machines, people who text and data mine large quantities of content. So you can see that we've got over 40 million of full text content, of full text papers directly hosted in core, and we've got over 100 million abstracts hosted in core, and this comes from over 150 countries basically around the world. How does content get indexed into core, basically? So there are certain requirements that we put on those data providers. We first start with a process which we call metadata downloading, and we expect that those repositories typically support a protocol which has a terrible name, and it's about 20 years old, and it's called Open Archives Protocol for Metadata Harvesting, otherwise called OAI-PMH. And OAI-PMH is routinely, by default, enabled by most repository platforms like DSpace, ePrints, Fedora, and so forth. What we effectively get when we conduct this metadata harvesting via OAI-PMH is typically an XML file. We process that XML file. That XML file can contain metadata of the content of those scholarly resources in a variety of formats. It can come in Dublin Core, it can come in extended Dublin Core, it can come in REOSC, it can come in open air guidelines, and there are some other formats around the world. What we do at Core is we process this, we harmonize it, and we try to make the best possible use of this and harmonize it and put it in our database. We then try to download those documents where those documents are actually available to us. This is actually even though this sounds really simple, this is actually a very non-trivial problem, because we are very often faced with the issue that in open access repositories, there are many links, and only some of those links actually point to the full text item that this metadata identifies. As librarians, some of you might be librarians, some of you might be researchers, but you will probably all understand that metadata should be unambiguously linked to the content that the metadata identifies, or the data that the metadata identifies. If you cannot link metadata to the data that it's describing, then we have a big problem. And unfortunately, that's what happens a lot, basically. So we try to solve that particular issue. And we need to apply a range of techniques for that. We then conduct various kinds of information extraction techniques directly on the full text to sort of enrich the information that we hold about those resources. And we sometimes also query external resources to find, for instance, discover identifiers or persistent identifiers for the resources which are actually not expressed in the metadata, but we know that they should be there, basically. And then finally, we index everything into a beautiful, nice, large index and make this available. I would really like to describe one particular problem that I find really, really key at the moment. Downloading of the documents from open access repositories has become a lot more difficult over the last 2 years, because all sorts of large language models and generative AI models are now using retrieval augmented generation to actually query those repositories very, very heavily. So whenever you type something into the likes of ChatGPT, it might query for evidence and look for evidence in institutional repositories. And these repositories are so hammered that they are really having a struggle to sustain that sort of load. And we have therefore conducted a survey of the repositories of our core members, and we realized that almost 80% of them, basically, or more than half of them, and only 20%, so more than half of them already limit and monitor and rate limit some of these crawlers. And in fact, only 20% still allow unrestricted access to all bots. So 80% are somehow limiting access to all of the bots that are coming from these AI systems. Thankfully, because we work very closely with repositories, Core maintains very good access. When we get blocked, we do get in touch with those repositories, and we have always been whitelisted. But I just want to highlight that this creates a situation in which some people have much better access to open access knowledge than others. And I think this is a key issue. I'm working with other people, with other experts on a working group that is addressing this issue of AI bots crawling open access content. I personally believe that this is a resource issue. It's very important that machines can get access to openly available information, because in the end there are humans behind these machines who will want to read these results, and it's in the interest of everyone for to be able to have trustworthy AI models, not untrustworthy AI models that are trained on Reddit. We would like AI models, of course, to be trained on valid scientific literature. So I'm just flagging that this is a big issue of our time. If you want to access content which is available in core, you have multiple possibilities. We provide these 3 data services called API, Dataset, and FastSync. The difference is, I think, quite self-explanatory. API is for real-time machine access to core. Dataset is if you want a data dump and you, for instance, want to train an algorithm or you want to analyze all the data. And FastSync is effectively the dataset together with frequent updates of the dataset. And there have been many application areas. I will speak about some of them later to the use of core. I want to go very quickly over this. Sometimes people ask me, how do we serve the people who provide the data? And so there are a few areas in which we serve those data providers who we consider to be our primary clients, but in fact also the users of the data are our clients too. So when we talk about the data providers, we try to increase their content's discoverability, and we we also help them to prevent misuse of that content. So we provide a range of applications for it, like search. We provide recommender systems for repositories, and we also provide a tool which is called the Core Repository Dashboard, which is effectively, so every webmaster will probably be familiar with something like Google Webmaster Tools or Google Search Console. And so what Core Dashboard is, it's effectively a console for a repository manager. So it's the same, it's the equivalent of Google Search Console or Google Webmaster Tools, but for repositories. It gives you information about how your content is discoverable. It detects issues with your repository from how the outside world can see it, and it provides lots of content management information and analytical tools about your repository. We also provide tools that support nations and that support basically certain institutions in terms of understanding their compliance with respect to open access policies. For instance, in the UK, we have a tool that supports open access compliance with regards to a REF 2021 and now REF 2029 policy. In the US, there's something called the Nelson Memo, which is a policy that requires access to federally funded research. And we are also working at the moment, and we will be releasing a tool called FAIR Certification, where repositories will be able to check their sort of setup. We will run various kinds of automated tests against them, giving also advice about what to improve. And then the repository will be able to certify itself, saying this is a repository which follows the FAIR, findable, accessible, interoperable, and reusable principles. We also make papers uniquely identifiable and resolvable with PIDs. A lot of people these days still believe that everything that is in the repository must have a DOI. Some people wrongly believe that unless something has a DOI, then it's not good research, which of course is a nonsense. But what we do, and because of these false beliefs, people often pay a lot of money for minting DOIs, and while there are free alternatives. So we don't mint these identifiers, but these identifiers are already minted. OAI identifiers are already minted by all repositories. They are uniquely available. And what we do is we provide a completely free resolver for these DOIs, for these OAI identifiers, which means that effectively we have an identifier that can be linked directly to the resource and to the splash page inside the repository. So this is and it comes completely for free. So if you're interested in that, you can also contact me later. contribute. So we are also working very closely with institutions to ensure that the metadata are complete. We provide a range of tools for enrichments like DOI enrichment, ORCID enrichment, and so forth. And finally, through the API and dataset, we make content from repositories more discoverable and more interoperable and more machine readable. So this kind of sums up how we work with the repositories community. Finally, I want to say here that we are representing and solving problems of repositories. We're representing them in a range of activities like participate in the Confederation of Open Access Repositories, Next Generation Repositories Working Group, on AI bots, on metadata standardization, and so forth. And we are community covered. I want to skip something, and I want to go now to the second part of my talk, which will be a lot shorter. And this is just about I just want to highlight some of the research that my group is doing in sort of processing scientific documents. And I don't have time to talk about everything, but I just want to give a few examples of the research that we conduct at CORE, and also about some research that other people conducted on CORE data, because I think that's kind of cool. So 2 years ago, we got the Best Paper Award at the Theory and Practice of Digital Libraries conference for a paper called Core GPT. And this was basically the idea, and this was before everybody started doing retrieval augmented generation, but the idea was very simple. Large language models are very bad in citing and referring to evidence contained in scientific documents. Can we use the core database as a backbone for doing an AI model that would effectively cite literature and that would not be hallucinating all the time? And this is what we have done. There's a paper behind it, and effectively the result is a question answering system that cites literature and doesn't make up facts, basically. We have then also very recently worked on building a new model for detecting and labeling all research papers of a particular institution in accordance with United Nations Sustainable Development Goals. So United Nations Sustainable Development Goals are effectively targets which the United Nations have set for governments, for organizations, and some academic institutions take them very seriously, and they want to understand how the work of the researchers who are working within those institutions is contributing towards those goals, and effectively which areas they are strong in and which the areas they are less strong. And so what we have developed in CORE is effectively a very scalable model that detects for every research paper your institution might produce the UN Sustainable Development Goals, and we have compared it to other models around the world and got the best possible performance. This is now fully embedded in CORE, and there's also a module. So if you log in with your institution to the CORE repository dashboard, you would be able to see you can see, for instance, an example of the SDG split for the Open University, and you can see that, for instance, we have a lot of outputs in quality education and also in good health and well-being. You can then, of course, look into each individual output, and some outputs may be labeled by more than one United Nations Sustainable Development Goal, because, for instance, there can be something that is about life below water, but also has reference to climate action. Another example, which I think could be really interesting for this community, is a project which is actually which I happen to be the coordinator of. It's called SOFARE, and it's about it's addressing effectively reproducibility and credit for the creation of research software. It's also this is also a project which is co-funded by Thatcher in the Czech Republic, because we have the Brno University of Technology as one of the partners. Effectively, what the project is about is that we're building a machine learning assisted identification of research software assets. Then we're sort of validating these identified research software assets by the authors of those assets, and then we're registering them. What am I talking about? So imagine that there is a research paper which looks like this, and then within that research paper, there is this sort of a sentence which says, the Advion Chipsoft X software capture an optimal image, blah, 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 blah. Okay, so what we would like to do here is we would like to automatically extract the Advion as the publisher, as the creator of the research software, and we would like to understand that there was some software used in order to conduct the research study, basically. So there's a lot of research software which is mentioned in research papers, but is never recorded. And therefore, if we don't ever record the research software, it's very difficult for people to then reproduce the study of the paper, because you don't know what tools were used, you don't know what was created, and in fact, this sort of unavailability of the research software that was used to conduct research studies is one of the key reasons for why reproducibility studies fail. Basically, it's not the only one, but it's one of the leading ones. So that's SOFARE. We have also received some funding recently from the Microsoft Open Data Campaign, and we are also doing some, and this is funding which we received, among other things, to conduct like a global study of the amount of openly available documents around the world. We are basically kind of trying to chase and understand how many open access contents which are downloadable, which are available with full text, are available around the world, and how many of them might actually be available but we don't know about. And so we're doing all sorts of research predictions, and you can see some of them here. And this is a project which we started a year ago, and so it's going to continue. We still have funding for another 4 years, basically, for this. Now I want to talk and just giving, I think, two or three examples of research that other people have done, not us, using the core data. So this is an example from the Erasmus University Rotterdam. It's from this year, and they have basically built the first large language model for social sciences and humanities. And they used the core. We gave them the core content. We gave them a data set. The data set is really large. It's, maybe after speaking about HPC, it's not that large, basically, but it's about 200 terabytes of PDFs, basically. But when we extract the full text from it, then we're only talking about, let's say, 5 terabytes. So it depends on what you need. If you only need the plain text, it's not that large. But still, 5 terabytes of plain text is a lot of text. It's an order of magnitude more than what you would find, for instance, in Wikipedia. So we gave them this text. They have built this first large language models for social sciences and humanities, and it completely draws on the core corpus. Another work which has very recently been done, also this year, is that at the TIB, Leibniz Information Center in Germany, in Hanover, they have built a tool called ORKG-Ask. This stands for Open Research Knowledge Graph. And this is a question answering system which uses kind of semantic web ideas, basically. And it draws again on the course content. It basically processes it, and it's kind of, to some extent, it's similar to the core GPT principles, but it's a service that you can use today, and you will be using the core dataset. And finally, I just want to give you just a quick overview of some of the areas for which the core data are being used. So it's often used by, we have clients, basically, Microsoft, NVIDIA, Meta, Anthropic. These are clients who are using the core corpus to build and improve large language models. There are some library discovery solutions that are relying on core. There are also plagiarism detection tools. We've been for a very long time working with Turnitin. Many of you might know this. They have a tool called Authenticate. And then very recently, we have started working with a company called GPT-0, and this might be very interesting for many universities, because this effectively, this is not a typical plagiarism detection. What they try to do is they try to actually detect GPT-generated text or any LLM generated text in student essays, basically. So in some circumstances, it might be undesirable that students generate their homework, basically. And in these cases, you might want to use something like GPT-0. We're also working with companies that are in the space of predicting, monitoring, or tracking innovation, and with some scientific machine translation. And I forgot here to mention here, we're also working with Grammarly, which many of you might be using for sort of grammar checking. So again, these kind of companies need large quantities of text, basically, in order to be able to tune their systems. And with that, I'd like to thank you very much for for your listening, and I'm open for questions.
Okay, thank you, Peter. That was a really interesting presentation. I think the questions will come in the end. But so we have 4 very interesting lightning talks coming up. The first one is from Petra Černohlávková. She's the head of the Center for Repositories and Metadata Support at the National Library of Technology. And she will be presenting persistent identifiers, PIDs, outside the Czech Republic. Please welcome Petra.
Hi everyone, so I will give you a little speech about the role of persistent identifiers in data management. So you probably all heard of persistent identifiers, and it's something usually known as URL or just ID, some code, and it's something minor, right? But why that matters? Like what the heck is there? It's the characteristics of the persistent identifiers that make them invaluable in the research ecosystem. They are unique, they don't change over the time, they are connected to each other, which means they allow us to connect every entity in the research ecosystem and lifecycle, connect them to each other effectively and easily. They are machine actionable, and therefore they save effort and time when finding and complying information. And nevertheless, they support a range of policy priorities like FAIR principles. But the truth is they are part of the FAIR principles because they are that valuable. And they are in the first levels. If you want to find the research data, you need to have persistent identifiers. Otherwise, you will struggle and will be more difficult to find those research data. So in the picture, we see the bit-optimized research lifecycle that allows us to exchange the metadata related to the persistent identifiers within the ecosystem from the research institution to funder and to other important stakeholder we need to exchange the data with or system. And that allows us to think about research as a graph that is connected through the power of metadata, because all of the persistent identifiers usually define their metadata schema. So, and as they allow to connect to each other, we can create these graphs. This one is from DataCite Commons that aggregates metadata from another identifiers related with the DOIs. So we now know that there are more than 52 million data sets with DOI, or related to over than 25 million people coming from more than 100,000 institutions. And these data allow us to make an analysis over that and understand more the problem and the research we are in. So we can get statistics about the institution, about how many publications are there, what are the citations. They are coming from the references as well. Also coming data from ORCID, which is also in my presentation, and you can read more about me if you're interested. And then we don't need those things to send via email before the conference, for example. But you can see there also when the person or the institution is active, what are the licenses, etc. So that allows also some decision makings for the institutions to go with or to understand what's going on. So what's the value in the persistent identifiers? It's, your data will be fair if you use persistent identifiers, or at least that's the first step to get there, right? And increase some efficiency if there are integrations and other people use the persistent identifiers, your research will be more seen. But the biggest value I see in persistent identifiers is your time. Because if there are integrations of persistent identifiers in the key systems within the stakeholders and you use it every day, every time when you do something with your data, and you reuse it afterwards when you are taking data from somebody else, it can save you a lot of time. There have been done several analyses counting how that will look like in numbers, so it's not just a theory like we know that saves you time. So we did one last year as well. And for the Czech Republic, it can get up to over 7,000 man days a year. And I think that's really cool. That's not like you can do something else, you know, you can stay in the lab and do the research. So I think that's worth it. So put it in the context of a use case. There is a researcher from Australia who used to spend weeks for grant applications before using ORCID. But the situation changed for him. He got lucky. He started using ORCID profile, allowed Crossref, one of the DOI registration, to update his profile with the publications and other outputs he got there. And also the funder created an integration within the system. So when he was applying, they downloaded the list of his works from the application, and that saved him 3-4 days for the application. So I think that's nice. So if you're interested in the complete story of Joe, who saved the time and how that helped him to feel more motivated, there is a QR code where is the link behind. But so what's the message is here is if you don't use persistent identifiers, then lots of the effort can be wasted because your research will be less found, less seen, less cited. And that would be pity because the researchers put a lot of effort in the research, and why to waste it, and why not to be fair if it can be something that small and that easy as this persistent identifier where we have a lot of support in there. So thank you for using persistent identifiers as much as you can.
Thank you so much, Petra. If you would have a seat in our beautiful committee that will shortly assemble in its full extent. Next up, we have Jan Fousek. Jan Fousek is a researcher in the Applied Neuroscience group at CEITEC, focusing on computational models and non-invasive brain stimulation. He's going to be presenting on repository for human and animal imaging and physiological multimodal data. Good job, me. Please give it up for, for Jan.
Thank you very much for the kind introduction. I promise we will change the name of the repository once it goes live. I need to switch heads a little bit here because I'm speaking here as a member of the MAFIL, Multimodal and Functional Imaging Laboratory in Brno. We are a core facility with open access, as in slightly differently what was talked about here before. You can walk in, pay us some money, and realize your research. For that, we have a quite unique combination of equipment. We have 2 MRI scanners, MR-compatible EEG, a laboratory for performing stimulation, non-invasive stimulation, and so on and so forth. And from that, we have been collecting quite a lot of data. We are part of research infrastructure such as Czech Bioimaging or Euro Bioimaging. We not only have the machines, but we also have the expertise to help you process the data and work with it and so on and so forth. And with this repository, which I will be talking about in the next 2 slides, we would also like to help our users to make their data findable and accessible for the secondary reuse. So the Multimodal Imaging Data Repository, that's for short, is being built on top of the National Repository Platform for Research Data. We aim to create not only the repository, but also some related services which will help users to work with the data. Of course, speaking about brains, we have to deal with sensitive nature of many of our data sets, meaning that these are not only identifiable, but also can contain some information about health of the participants. So appropriate measures have to be taken. And maybe for the multimodal, this is a slightly overloaded term in our repository, meaning that we not only have multiple modes, such as based on the machine which acquires the data, like MRIs or EEGs and so on and so forth. We also have multiple species, because we not only at our facility we measure only humans, but other communities which will be using the repository. They work with rodents like mice, rats, and so on and so forth, monkeys. And we also are not only limited to brains, because these, like MRIs and these machines, they can be used to also image other body parts, such as spinal cords, joints, and so on and so forth. So to make all this work, we have assembled quite a also multidisciplinary team, based not only from our experts, but we are also dipping into our friends in CEITEC Scientific Cloud, and also already mentioned eBrain's infrastructure for digital neuroscience. Maybe just to frame how we want to handle, or what kind of issues we have to deal with handling sensitive data. We approach our data set or our data on a data set level. So we are setting the access control on data set level, not only on the individual images, for example. We envision having multiple access modes. Either some of the access might be completely open, some will have to be approved either automated fashion or manually. And of course, all the identifiable human data is handled under informed consent. The second part is that we would like to not only handle or help our users to make their data available to other partners, but also provide them with some research environments, virtual research environments, where they can actually work with the data. So that's the trusted research environments. Coming soon, let's talk about this into the discussion. So thank you very much.
Thank you so much, Jan. Very interesting, very lightning talk. So loved it. I'm excited for the new repository name. Can't wait. Let me know when it's there. You know, maybe I'll finally get to pronounce it correctly. All right, next up we have Antonín Fejfar, who's from the Institute of Physics of the CES, studies thin films of nanostructured semiconductors for, oh, here we go again, photovoltaics and photonics, and has led multiple international grant projects. Please welcome Antonín Fejfar.
Thank you. So I honestly don't know how I deserve the honor to be invited here, except that I think I'm kind of a object of the National Data Initiative. I'm one of your use cases, or maybe one of your guinea pigs on which it is being tested. I listed my colleagues who would contribute to this, and I was specifically asked to talk about OneData, which I will do in the end a little bit. What I want to tell you is three things. The first one is our needs, then our approach, and then finally the solution, which I can hardly name as our own solution, and you will see why. So let me show you the Czech Nanolab research infrastructure, instruments, which we are partly responsible for. There is a database which lists altogether, now the number is about 160 instruments, so I would go through pages like these, and you see the diversity and what the users can do. They do a lot of approaches, and we all struggle with the data, what has been already illustrated. The approach, how to deal with that, is Yes, and I included this one. The red button is not to shoot, but to end your experimental session. The instrument booking goes through the booking system of the CEITEC. And this is important. That's a tool which has been developed over the years and became actually quite a sophisticated tool because it is not only reservation, it also serves as a logbook, it serves also as the tool how to do the data transfers, and it becomes quite sophisticated. It is now being adopted not only in CEITEC in Brno, but also at the Institute of Physics. And that already shows quite a lot of troubles and issues because as we have a diverse instruments, we also have a diverse ways how we want to deal with the data. And for that, the approach which was selected by CEITEC was the OneData, which is there as a distributed service for doing the data transfers. And this is my final slide, but the actual slide which describes the situation is the one which has been presented here at the last time, at the previous year. And it was presented by somebody else, by Andrej Filip, Tomáš Svoboda, and Adrian Roshinec. And so all the credit goes to them, and you should have invited these people, not me. But the purpose has been served because it was in the program and they contacted me and I found about them. So success, the conference works as it should. Thank you.
Thank you, Antonín. You say it's an honor for you, but actually it's an honor for us. All right. Are we ready? Yes. Next up, we have Illyria Brejchová, who's from the Institute of Computer Science at Masaryk University. She's a repository system specialist in the National Repository Platform project, guiding user communities through the process of creating domain-specific repositories. Give it up for Illyria.
Thank you for the introduction. I'd like to take the next few moments to remind us all collectively of one specific aspect of the NRP approach to building repositories. Specifically, the approach I want to talk about is the focus on domain-specific repositories over institutional ones. This decision was not a trivial one. In many aspects, building institutional repositories is simpler. However, the benefit for the end users of domain-specific repositories is great, and I personally believe, as I hope all of you in this room, outweighs the costs. However, it is worth mentioning what the consequences of this approach are and what specific challenges and opportunities it comes with. Institutional repositories are more simple in a way because they deal with very generic data. This means we can use generic out-of-the-box solutions with minimal configuration. On the other hand, domain-specific repositories are more in tune with the specific needs of the domain. They integrate domain-specific vocabularies, standards, data previewers, and they can be governed by the community itself. It is the research community that drives the development, and it is them that know where the field is going and what is needed the most. However, institutional repositories are more in line with the current way science is funded through institutions, so it is easier maybe in those respects. It's not this slide. So looking now specifically at domain-specific repositories, One great opportunity that I see is that domain-specific repositories can gain international importance more quickly than institutional ones, which by definition its scope is only as large as that of the institution and serves only its members. The community ownership is really important for me. I already talked about that a little, but the user needs really need to drive the development in order for the final products that we build to be used and appreciated and to actually make the research easier. However, building more complex systems for research, which is ever evolving, is challenging. And we need the users to be able to communicate what it is they need the system to do. And we need to validate that the things they communicate to us are actually what they need, and then find the best technical solution to implement them. And we also need to find ways to secure the long-term development of these solutions. To end my presentation, I'd like to highlight what it is we as the National Repository Platform are providing. We are facilitating the communities, giving them the opportunity to build their repository by providing a shared technical infrastructure to run these repositories. And we are also providing methodological support and guidance, facilitating the sharing of best practices within the community for repositories that are currently being built, as well as those that are already built and well established in the Czech and European environment. So thank you very much for your attention, and I look forward to seeing many of you on the workshop tomorrow.
Thank you so much, Illyria. Please take a seat with us. And we are now complete. Whenever I hear user needs, I get like really excited because I'm a UX designer. So I'm like, ooh, yes, user needs. So thank you for mentioning them, because they indeed are very important, especially when designing repositories, let me tell you. All right, next up, we have the Q&A session. For that, if you need the Slido QR code, we have Zuzka here. Who has it? So if you want to put your arm, it's a bit lo-fi. Okay, yeah, it's a bit lo-fi. We are back in the Stone Ages, but we're doing what we can. So if you need it, just you can put your hand up and she can come over, or you can maybe scan it from far away. Number? Oh, is it? There are plenty of QR codes, but unfortunately not this one. All right. So, before we open the floor for questions, let me introduce the chair for this session, Luděk Matyska, who's the chair of the IP's EOSC steering committee. He's a professor at the Masaryk University, director of CERT-SC Center, and represents Czech science on the Elixir board. He contributes to the strategic planning and implementation of EOSC in the Czech Republic. Please give it up for Luděk Matyska.
Thank you for the introduction, and I would like to start thanking to all the presenters. We have had a very nice presentation about what is possible to do and what we can actually try to achieve when we have a large enough collection of open or at least accessible data like we had with the core repository. And then we have heard few messages about how to build or what aspects we need to actually build an ecosystem which will provide us with the data and access to the data. The first keynote presentation was related to the open access, to the documents. But the rest and the focus of our own conference is naturally on the data, which is much more complex environment and much more difficult. And one thing which is important to understand is that we are in fact building a part of the large ecosystem of infrastructures, because the data are usually produced by researchers. We have quite a lot across country, across Europe, quite a lot of very nice ecosystems and frameworks around what we call infrastructures. And those are usually the forerunners for taking care of the data. And one thing which is important for us is to understand the interaction between the infrastructures and what we are doing with the third data, what we are doing, what we call EOS in a country. And I would like to start, before I will give floor to you and also to people, I mean, through the Slido or directly in the here present, those who are present here, is with the first question, which in fact somehow continues what Illyria had in her discussion, and it is to any one of you, what do you think is proper motivation or things which are behind the person who is creating data, producing them, and then selecting a repository? Because Illyria presented the institutionals, the domain repositories. We have heard about the meta repository of the core, in fact, the one which is harvesting the others. And what do you think are motivation factors which lead a person to make the decision, I will store the data in a particular repository, how the selection process goes? And because we had the Illyria starting, I will give the first opportunity, Illyria, to you, but then I would like to hear also from Peter Knoth remotely, and then giving floor to you as well, Illyria.
I honestly believe that most researchers use what their colleagues are using. And it makes sense to me that users go the path of the least resistance, finding a solution that is easy and available. I'd hope that they have someone in their team that is a data steward that understands the environment of repositories, that can set a good best practice, and then they follow in those steps.
Yeah. Thank you, Peter. Your opinion.
Yeah, thank you. So this is a really good question. I think that the really key point that is driving the selection of where you deposit is often policy. So at many institutions, it is an institutional policy that you need to deposit all your content into the institutional repository. I think it's a very good policy. I would basically like to compare two countries which have a very different approach to this. In the UK, it's a complete standard that you must tell your institution about all the research that you have published, basically where you have an affiliation, so that the institution has an understanding of the kind of knowledge assets that it produces. I think this creates a really great situation where basically you have like the institutions are aware of what they are producing. A completely different situation is actually in the United States, where institutions very rarely have an understanding of what their institutions are producing. And if you think about it these days, the institutions are, or academic institutions, to some extent, they are businesses. They operate in a way that, especially US institutions, which receive a lot of money from students, basically. And I can hardly imagine that there would be an organization, a sensible organization, that would not know what knowledge assets it produces. But it is happening. Big institutions in the US don't know the papers that their academics are producing. And I think that's completely crazy. I think if we want to build proper open access, if we want to have good governance, if we want to have good if we want to be good stewards of the data, then institutions really need to take responsibility of of understanding, collecting, curating, and and analyzing perhaps all the knowledge that their academics are producing. I would maybe, the last point I want to mention is that very often people believe that by registering something, let's say a persistent identifiers with a resource and registering the metadata with a third party and commercial entity is going to somehow deliver preservation of that resource. And it's actually not completely right, because it doesn't preserve the resource itself. It just preserves the metadata. And then I would basically think maybe also from the following perspective. Many institutions, many universities have been here for centuries, but the organizations like Crossref, DataCite, and so on, how long have they been here for? And what's their business model? Their business model is that if we stop registering PIDs and we stop paying basically for these business models, then they will collapse. Are they really more persistent than the institutions themselves? And I really would argue that the universities are a lot more persistent. And therefore, I think that institutions need to take ownership and need to be those who expose the metadata and preserve the assets. That's my opinion.
Thank you. I will comment on it after I will hear from the other members of the panel. So if you can share the...
I was reminded by Petr Knoth about the situation in my discipline. I'm a physicist in photovoltaics, and if you, I very often have the question from the audience, how long do the solar panels actually last? What is their lifetime? And I tell them, you typically get the guarantee 25 to 30 years. But don't rely on that, because I don't know a single company which would last that long. And we have the same situation here. Actually, we have to keep in mind, and I'm glad that Petr picked it up. This is very, very important.
I think it boils down to the initial motivation to share the data in the first place. So if it's an obligation that from a certain grant, I'm supposed to publish my data in a repository, then I go through the path of least resistance. If I'm making the data set in the first place as a main result of the research, then I would go as a researcher for a repository with the highest visibility and prestige.
Yeah, I rely with that. Like for now, we can feel more the pressure from the funders to put the data out without being really confirmed that that's worth it and there is a value in there. So they go for the easiest solution, whether it's to ask colleague you sit next to, or it's just Zenodo because it's there and everybody knows. But if we build the trust for the repositories and data management and the value of it, then I believe that they will listen better to the data stewards and select the repository that will fit the needs the best, not for the easiest solution.
I will try to comment on two things. That what I see here in these answers is that we are, and even we are, people who are within, are mixing several things together. Because one is the sustainability. Who is taking care of the data? And who is making sure that the things and all the metadata infrastructure and environment will really survive? But the other is, and this was not, from my perspective, surprisingly mentioned by anyone, and this is how much care you really put as a repository owner and repository producer to make sure that the data there are really properly curated. And Peter, what you mentioned, I will challenge it that this is very well working for the data as, or the text and bibliography and documents as the assets. But when we are speaking about the data, we are in a very much broader environment. And there are data which are huge, which are excellent only if they are collected together. So if we, for example, take things like the radio astronomy things, which are done across the whole board, and every institution will keep only their own, then either we have to create a layer which will connect them, or we will never be able to actually use the potential of the data because the data will never be processable together. So there, and the other thing is we will have different quality of the curation at the level of the individual institutions for the same data, which will make very difficult or almost impossible to actually connect all the data together because everyone will have to deal with the problem of quality. You are in core, in fact, doing it by harvesting all this data and taking another care of them. And even you are working with hundreds of terabytes of the primary data, which is peanuts when we are going to the astronomy, where we are going to the microscopy, where we are going to the genomics, where these things will not be at the level of hundreds of terabytes, but will be a level of the hundreds or thousands of petabytes of the data. And even moving them in this world is still impossible. It is still something which is technically. So I'm just, and this is the input for my second question, still to the panelists, and that exactly goes, who you think, and this is almost answered, but still, who you think should be responsible, and that the governance layer, for responsible for taking care of repositories. Because if we, say, at least for the moment, if we agree that the institutional repositories, which are just, I somehow call them a kind, no, I will not tell how I call them, which are simply difficult to maintain across all the disciplines properly. But we agree that the institutions themselves, hundreds of years are, of the legacy, are probably the institutions which will be there even after we will not be here. How do you see who should take care of the repositories? I mean, you can say simply, oh, institutions, and then it's done. But if we are speaking about the domain repositories, like Illyria had in her presentation, who should be responsible for such a thing? And try to start the other way around. And Peter, you will be the last to answer that. Thank you.
A similar situation with the persistent identifiers when the value is when most of people use it. So taking care of the repository in a long-term run, as you mentioned, the repository might be here and we won't, is something you cannot go and do alone. And you need to go with somebody you can trust and who takes that seriously, the responsibility that lies there with the repository, and it's not something you think that will disappear in 2 or 3 years, but that's a commitment for the community you are going to work with. And I think that the nice advantage and opportunity there is the infrastructure going across Europe, so you are not working alone just here as an institution, even if we are talking about the domain-specific repositories especially.
So if I understood it correctly, something like a consortia of with common interest of institutions with common interest. Thank you, Anna.
Yeah, across the country, if that's possible.
Or across the continent or globally.
I think, yeah, basically agree. In my view, is the research infrastructures who should play a very strong role in establishing and running these repositories. But with the institutions, as in we throw around the word institution, this can mean a lot of things, but let's say universities playing an active role in this also, so that we avoid this problem that this is something which is being handled, we don't care, this will be always here. So to get some participation of the domain scientists.
My honest answer is, I don't know.
Okay, it's fine.
Really.
You can pass.
We pioneered it and we do not know.
Thank you. I agree with what was said. I think that of the people managing the domain repository need to be the people that actually understand what the data is in it. They are the people who are deciding like for how long this data actually needs to be preserved and how useful it is. And they are the people doing the data curation. These people need to be backed by strong research infrastructures that will give them the technical support and the financial support to do what needs to be done. But these research infrastructures, their members are institutions which have the longevity and which are in themselves incentivized to produce top-level research and need these research infrastructures and data services to do that.
Thank you. Peter, if you can.
Yes, I hope you can hear me. Okay, perfect. So I just wanted to say that I agree with Professor Matyska actually on the point that sometimes the data are really too large, basically, to be handled by the institution themselves. And in that case, of course, it makes sense that the data itself is stored in some sort of specialized centers, perhaps the domain repositories, or it could be within infrastructures. But I think in every case, without many exceptions, the institution should at least hold the metadata about all the assets that it produces, because that is always manageable. So that's now coming to the question of who should take ownership, who should take the responsibility for the running of the repository. One thing that I'm seeing, for instance, in the UK, is that some institutions are forming some sort of consortia. So there's an example: the University of Leeds, Sheffield, and York have formed a consortia called the White Rose Consortium, and they run together one repository. And that's the way how they are basically, still within the repository, you have still sets, you can still see which outputs belong to which institution. But basically, I think their strategy is that this cuts down the cost of running the repository. I think that these points are really reasonable. I just think that it's important that it's, as it was said, that institutions should really play a key role here. I would really caution against just one thing, which is that we create some sort of a monopoly provider, that there's just one institution that is a third party, something like a repository, like an Elsevier repository, if I can call it this way. And basically, we rely everyone basically on that one data provider. And if that one data provider hikes prices, then the whole academia is in trouble. So that's my only worry. I don't think we're going that way. I think as long as we preserve decentralized ownership and decentralized infrastructure, then that's good.
I will ask Dominika whether we have some questions from Slido. Do we? So please, if you can. Yeah.
So the first question is for Petra. Isn't the centralization and commercialization of PIDs of, for example, DOI a problem? How does it compare to the centralized approaches, for example, persistent URLs?
The DOI is a foundation, and the commercialization we are talking about probably, DOI has more levels. So, and the ground, it's all handle. So you use handle or DOI with the services above, and the DOI is a foundation, but then you have the registration agencies with different funding models. So if you don't like one payment model, you can go to the different registration agency that will offer you different services and will have different requirements, or you can just use handle. So the advantage of DOI are the services above, and because there is this fee model we pay for integration and assigning DOIs, then they can do the extra work on the DataSite Commons I showed you with Open API, so you can download those data and reuse them. So then maybe the institution doesn't need to collect their own metadata about the research data, can get them from tools like that. And it's possible because of the strong that these agencies and supporters of persistent identifiers have. Because what support do you have for handle? What can you tell about that and how to use it? So it's also part of the using persistent identifiers is building the trust. And for that, you need resources. It's not built itself. it doesn't happen miraculously. And for example, for ORCID, it's even more complicated because the focus is on giving the rights to the author, what will be shared or not. The author and the person who owns the ORCID profile has the authority to decide who will be seen and who will see those informations. So, and I think it's important for the researchers to know that they can decide these things. But again, you need infrastructure for that, and that costs something.
Is there, Peter or anybody else wants to react on this question? Because it makes it interesting for all of us.
Maybe just very briefly. I'm not against the DOIs per se, but I would say that the model, which actually is not just unique to DOI, but it's also common for ORCID, is kind of business-wise genius from my perspective, but in a slightly evil way, because effectively, the typical situation in the world is that if you curate a database, then you invest a lot of resources, and then when someone access these resources, then they give you something back because you had to invest basically. And the DOI as well as the ORCID model is kind of reversed. It's reversed in this sort of ironic way that if you are, these agencies provide an empty database, and those who contribute to the database have to pay for the improvement of their database, which then everybody gets for free. And so it's a very strange reverse model. I'll be quite honest with you. I don't like that model. I think that model is business-wise wrong. And what I would really like to see is that institutions actually make resources available and that they use some principles of decentralized persistent identifiers, which do exist. I want to point out, I talked about OAIs, but there are also others. There's also ARC IDs, because in the end, what these persistent identifiers are, they are actually URLs. That's all that it is. There are URLs that are resolvable basically to some space, and I think it's doable. And I think we are often. I think the problem is that we often conflate the use of persistent identifiers not with discoverability, but with prestige. So if we say, for instance, I have heard it from many people that they feel that if this doesn't have a DOI, it's not a proper paper, basically. But we forget that, for instance, some of the best papers in the world, like the NeurIPS paper that, for instance, changed the world, which created the first large language models, or for many years, all papers on archives didn't have DOIs, basically. So it shouldn't be conflated. I think that's my point, and there are alternatives. It's not just DOI, but don't interpret this as me talking against DOIs. I'm not sort of saying that minting DOIs is wrong.
Do you use or support any other, perhaps more modern harvesting protocols in core than OAI PMH, something based on RDF or linked data?
Just to answer this, there is a protocol which was created, the protocol, the OAI PMH protocol was created by a team around a guy whose name is Herbert van den Sompel. He's a really clever person. He is also on the advisory board of CORE. And he also, with his team, developed another protocol called ResourceSync. And it's nearly like 7-8 years old, but unfortunately it hasn't been picked up by the repositories. So like at CORE, we can totally support ResourceSync, but we don't see repositories exposing ResourceSync to us. And I think that's the challenge. So I would really like to see something better. I think a lot of people are of that view because OAI PMH is kind of slow for synchronization. I just hope it's going to come, and maybe it's also a time for us to do something about this. So thank you very much for the question, and it's a great one, but unfortunately there's no immediate answer.
I will make, before going to more questions, do we have more questions related to the data, please? Not to the documents, but to the data.
Metadata, maybe.
Fine.
Okay, so it's not another question for Peter. What steps are you taking to ensure that linking metadata to data files is unambitious?
Thank you very much for this question. I'd love to answer this. So at Core, we provide the Core Data Providers Guide, where we actually say for every specific metadata schema, how to do this in the best way. So for instance, we say that for Dublin Core, you should put a direct link to the file directly in the identifier field, for instance. But for other protocols like OpenAir guidelines and for REOX, we give a slightly different advice. So I would just say, go to the Core webpage, look at our Core Data Providers Guide, and we specifically say how exactly this should be done. And if it's still not clear, then feel free to contact us.
Okay, and some question to the other panelists. Okay, try to select one.
We have one for Illy. The question is, how do you ensure that all these different domain-specific repositories adhere to the same quality standards?
So I guess the first question here is, we maybe don't want them all to adhere to the same quality standard, because that is domain dependent. And one of the big challenges of building a domain repository is coordinating the community and having them agree on what the quality standards need to be and what makes sense for that repository. And of course, it always needs to be a good trade-off of the resources and time that it takes to achieve that standard, and having a good cost-benefit balance. And I think using electronic lab books and similar tools that help automate lots of the processes are essential for that.
Anyone else want to comment on that? Okay, do you have any more, or will we return back to?
We have the very last question. So it's to Peter. And
no.
More technical maybe. So what is the process for DOIs and ORCID or any persistent identifiers enrichment? What exactly do you offer?
Thank you. I'm really delighted by the interest. So really, really appreciate it. So what we do is that basically we process the metadata records directly from the repositories. And it's very common in repositories that, let's say the repository doesn't expose the DOI of the material. This could be for many reasons. One of the leading reasons is that, for instance, the academic at the time they are depositing the article doesn't know what the DOI is, because the DOI hasn't even been minted yet. This happens, for instance, when you're depositing before on acceptance, before effectively the publication of the resource, which is common. So what we do then is that we actually triangulate the data with other repositories, basically, other registries, so like the Crossref or the DataCite database, and we try to find the same paper basically in those other places. And then we have a module within the core dashboard, which tells you that for this particular resource that you have in the repository, we have found the DOI, or we found ORCID for all the authors. The idea is to cut down the time of the repository manager, to help them to basically manage the repository properly and curate the metadata. So what they can do is they can go to the module, download the CSV file basically from us with these enriched persistent identifiers, and they can then put this into the metadata records. We are working now with a company called For Science that is producing DSpace on actually directly integrating this between like doing an integration between Core and DSpace, so that it wouldn't need to be even downloaded via the CSV, but it could be completely like synchronized automatically.
Thank you. I mean, I will give. We have just few minutes for the end, so I will have just one question to the panelists. But before I will go that direction, and this will go more to the infrastructure and building the repositories. I think that one thing which is very relevant to the discussion which we had about who is and should be responsible for building and taking care of repositories and the risk of having a monopoly, we can see currently very nicely with the things which are now happening in the US, where even things which we trusted, if you follow this area, we had seen that things which we trusted are there for indefinite thing and have secured source of funding are disappearing or are in a very huge danger of disappear. Europe is trying to take some steps, but for me, the major thing to take as an information and knowledge from that is that we really need solutions which are distributed, which are decentralized, where the decision on any one element of such a thing will not destroy the whole network. And this is something which we have to take as a very important message for building the whole ecosystem of the repositories and also the individual repositories. That whenever we have just a single institution, whenever we have just a single stream of funding, these things are extremely endangered if situation change. Because the university may survive, but the funding for a particular thing supported by a single institution, single university may not. And when we are speaking about the data, this is something which is extremely important. And now I have the last thing for the panelists, and this goes to the questions which we had agreed on. And this is the building of the repositories. And I would like to give you the opportunity to simply comment, rather briefly because of the time, what do you think is either the major challenge for those who are building repositories to make them attractive, I would say, both for those who are storing and those who are there to look? And eventually, what do you think is the major user problem? And you can select what part you want to answer. The major user challenge to actually accept the ecosystem of repositories instead of keeping all the data just in his or her own desktop. And I will, Peter, I will give you the word at the end, as you started at the, and I will again start Illyria with you, and then go through the panel.
Thank you. I'd say there are a number of things. One of them is that data management, like the data itself, is really complex. So creating complete metadata, it can be overwhelming. So we need to, again, come with tools to make it easier and agreeing on a very reasonable standard of metadata quality so that it is useful but not so detailed that it is absolutely overwhelming, especially if it cannot be created automatically. We need to provide good methodological support and documentation for users and training, and make sure the user experience is as smooth as possible. So that is for the users, and user testing can also help us achieve that.
Our major problem is the time. We are struggling with time because the approach is we want to pioneer examples which people could follow, as was said by Illyria. And if those examples are coming as natural approach, the others will follow. It should happen as if it is completely natural and doesn't take any effort at all. It's as simple. But doing that is difficult. And we are struggling with time. The approach of CEITEC, for example, we are adopting it as the Institute of Physics, it does not work. Because there are some settings which the server was not accessible, the last result from yesterday, and like that. So we are struggling with time breaking through.
I would say incentives, but let's not go into that. Then I think it might be skill issues on the level at the user level, because many of the repository systems, when you actually want to upload the data or download the data, it's the basic level of interaction with the repository, expects you to be at least half a computer scientist, right? Users want to drag and drop, and that's it. We are trying to elevate that with the virtual research environment, where we can prepare at least some helping services for the users to do this. But again, this will take time to develop and make sure that it actually works.
Yeah, I think that both sides, whether we talk about those who are building the repositories or the users, what they need is patience, because the repository is not built in a day or in a week. It's a process that takes time. And even though when you do the release, then there are some things you would like to improve for the user experience. And that's the process going forward, and you keep going on to make it easier and easier. Maybe one day if we just drop the file and everything be there, but that's a way, it's a long way. It's not something that will happen shortly. So the patience is something I find key.
And Peter, your word?
Yeah, I really agree with all the challenges related to lack of resources, lack of human time, and so on. But I would like to add one more, which is that I think we need a major challenge is the perception of importance of institutional repositories and generally repositories in the eyes of the institution itself. My experience is that the libraries are usually the last places that the institutions want to fund because they have limited resources and they will fund everything but the library basically somehow. And libraries tend to be those who run these repositories, and I think that's a really big struggle until institutions understand that repositories help them to somehow understand the work, the research that the institution is producing. Maybe there will be in the future some tools that will help institutions to sort of say that if I want to do at Masaryk University or at any other university better research, I need to understand my current research, and maybe there are ways of how we can measure it. So until we start using repositories as an analytical tool, then I think we have a problem, because it won't be perceived as important for the institution itself.
Thank you. I think that this is something which we can end the whole panel. I mean, as a thing which you probably should take from the discussion is that building repositories is not simple. It takes time. The repositories themselves, and this is, I think, the excellent presentation at the beginning, if we collect sufficient amount of data, the data are becoming valuable per se, not only for those who produce them, for the few which are immediately using them, but with much wider use. And this is exactly why we are trying to do all these things. And the other thing which we should take with us is that we should be aware that the monopolies can help us because they provide some added value service. But at the same time, we have to make sure that we are not absolutely dependent in terms that if they fail for any reason, we are left completely in the back without any option, that we need additional versions, additional options to make sure that whatever happening, we will be able to survive, and we will have not only a single repository, we will have not only a single library of data, that we have a huge ecosystem which is moving slowly than if we have just single one, but which is much more stable and much more guaranteed to be with us in the future. So once again, my thanks to all the presenters, to all the panelists. Thank you for the question which came from that. And I think I will leave to you to announce what is the next, although I have some suspicion. Thank you very much. Thank you.